Hello everyone, my name is Kundan Sharma. Today I am here to do numerical calculation on multi-particle system, which is chapter 9 of my physics 221 class. And the question is, a boy is playing with a yo-yo of mass m on a low mass string. So let's just consider this to be yo-yo, and this is the height that yo-yo falls, and the weight is acting downwards, and its magnitude is mz, and his hand moves up a distance d. It is said that his hand moves up a distance d, and the boy pull up on the string with a force of magnitude f. So here we are asked to find what is the change in the translational kinetic energy of yo-yo. So let's first consider the point particle system, and here the system is point particle of mass m. Surrounding is earth and hand. Initial state is the point particle with the initial translational kinetic energy, and the final state is the point particle with the final translational kinetic energy. So we know that uh, now we know that the translational kinetic energy would be net force times the displacement of the yo-yo, that which is displaced downward. So the net force would be the force applied by the boy on the yo-yo minus the weight of the yo-yo, that is F minus mz, times, and the net displacement would be delta y. And we consider the center of the mass, since we are using the point particle system. So from the picture we see that the displacement, that is delta y, is equal to, here since we take downward direction to be negative and upward to be positive, the displacement is downward, so h would be minus h deltas. Therefore delta y is equal to minus h, and the translational kinetic energy would be F minus mz times the displacement, that is minus delta s, that we calculated to be mg minus F bracket h. Now let's look at the second question. The second question is asking us what is the change in the rotational kinetic energy of the yo-yo. Here we take it to be real system. Here, since the question is asking for the rotational kinetic energy, we cannot use the point particle system. That's why we use the real system. So here the system would be mass and string, surrounding would be earth and hand. Initial state would be initial rotational and translational kinetic energy, and final state would be final rotational and translational kinetic energy. And from the principle of energy, here we know that total energy would be work done by hand and work done by earth. That's the only two energy that's being applied on the yo-yo. And total energy would be the total translational energy plus total rotational energy would be equals to work done by hand and work done by earth. And the work done by hand can be said as force times displacement, and work done by earth is, we know, the potential energy, and we already know that we took downward direction to be negative direction. Therefore mz is going to be minus mz and h is going to be minus h. So here what we want to calculate is the rotational kinetic energy. So in doing the simple algebra, we just get the translational value of translational energy, as we know, we already calculated on the previous question, and we got mg minus f times h. And doing the simple algebra, now we get the rotational energy to be fd plus mgh minus mg minus f bracket h. So if we simplify that, we get the total rotational energy to be fd plus h. So this would be the total rotational energy of the yo-yo. Thank you. That's it for today.